All right, let's look at PSOC and pins, but also counter. So the PSOC creator environment can use small scale integration type devices. It's built into the chip, and you can put in things like D flip-flops and inverters, and it'll program it, and it so you don't have to wire it on a board. All right. So here we have like a counter done 3 different ways. Here we have a flip-flop, and we feed back the Q naught, and so that's toggling. Then we feed that into the next clock, so that's half the frequency of that, half the frequency, half the frequency. This is a ripple counter. Then there's a T flip-flop, which is essentially what we have right here, and you just enable it with 1, and it ripples through, right? But there's actually a counterpart in PSOC. All right, you can tell how long you want to count. And that's just fed off of this clock. Now the kit I have only has 1 LED. All right, so rather than look at all 4 bits, I'm just going to take the slowest clock there. All right, it's a digital output, and it has a hardware connection. That way it's connecting to the outside world. All right. And we have 2 pins. This is what so pin 2 is a digital input pin, and it's got a hardware connection. All right. In order for the code that I'm about to show to work, you have to kind of give it a precondition. So if there's no input, there'll be a resistor that pulls this up to VDD, an initial hard drive, okay? Otherwise, what I'm about to show you won't work. Well, in the C code, you can write pin 2, 0, right? And then you can read that pin 2, read, and write the opposite of it, and then there's a delay, right? So every 100 microseconds, we're toggling that pin 2. And just to be clear, the CPU is on the whole time, all right? If I wanted to make sure not to use the CPU, that clock I could just bring in a system clock, and then this whole thing would work without ever waking up the CPU. So right now I'm testing this counter, and actually 4 bits come out of it, and you have to assign which bit goes where. So this is the slowest bit. So if we just build it, okay, we should see the blue LED blinking. All right, let's look at the webcam. And so we can see it blinking rather slowly, but it's blinking. Now, if I press Control, I can just move that part. So now this is the T flip-flop version. All right, that should be ready to look at. And it's blinking. And then here is the ripple. It's built out of smaller parts, but it's still a ripple toggle counter. And it's blinking pretty much at the same. Now you might say, what are the various advantages and disadvantages of it? Well, if you're trying to learn what a toggle flip-flop does, you probably want to use this because you can see the logic quite clearly. If you just want to use a toggle flip-flop, well, then this is probably the best abstraction. But like, what is the actual difference here? Well, in both the toggle flip-flop version and the D flip-flop with inverter version, we have a clock, and then that clock feeds the next clock, and that clock feeds the next clock, and so the clock signal is rippling through. Same thing here. So in fact, these aren't all changing at the same time. This changes, that changes, that changes, that changes. Here, these outputs all change at the same time. And so what I had done earlier is I put an AND gate, 3-input AND gate from all these outputs and tied it together. And if everything were the same, right, the LED would just stay on, right, because all the inputs would be actually, it should blink. Excuse me. It would blink because all the inputs would be on at the same time, and all the inputs would be off at the same time. So it should just blink at the same rate. But because of that rippling clock, it doesn't. The duty cycle is off. All right. But the key, I guess, the key point is, I can have a pin here. I can configure it, digital input, hardware connection. It does get connected on the chip, but you can read and write to it from software. And so you can do so much more, but for the that DAC project, right? We can make that a digital input. And that's pin 4, and maybe it'll compile this time. Yeah, so that was the, oh, it didn't. So I have a feeling I'm going to have to trick this into thinking something is there. Because it just says nothing's connected to it. That's okay. I have messed up the C code. And that's okay. I'll fix that later. But really, we start the op amp, we write a value, and then we can toggle it. And so I could do that for 3 times. This, I guess, didn't matter. Still needs a bit of work. But again, you don't need the function generator to have 3 inputs to get that to work.